Okay, we're taking a look at the solutions from number 11, where we're talking about common factoring. Common factoring is very important, and it's remembering what is the same between everything. If there's something, take it out. That is the goal here. Same, take it out. So what is the same between 8 and 18? Well, we know 2 is going to be the same between those. What else makes up the numbers 8 and 18? Well, 8 is divisible by 2, it's divisible by 4, it's divisible by 8. Unfortunately, 8 is not divisible by any of those things. So the greatest common factor there is 2. What's the greatest common factor for B? That would be 5. For C, both of those terms can be divided by 4, but wait, they also both have an x in them. So we can take a 4 out of those things, but we can also take an x out of those things. We can take an x from here, and this thing's actually got 2 x's, so instead of x squared, it's just going to become x. So 4x is the greatest common factor. For this one, what's common here? Well, everything here we can also take a 4 out of. 4, 8, and 12, all divisible by 4, and everything has at least one x, so we'll take 1x out. So we're going to find the greatest common factor here, and then we're going to write the binomial in our factored form. So 3x plus 15, so we're going to take out a 3, and then what are we left with? Well, if we take out a 3 from x, we're left with x, and if we divide 15 by 3, we're left with 5. For B, For B, what's in common between these things? Well, we can definitely take a 4 out, and we can also take an x out. So if we take a 4 and an x out of 4x squared, you're just left with x. Plus, well, if we take the x out, now it's just 8. If we take the 4 out, we divide that, so it's just 2. Next, we have a 5x, which is common. That's going to leave us with an x and a minus 2. Here, we can take out a negative 7, because that's also divisible into 21. And we can also take out an x. And then what are we left with? Well, here, we're going to be left with 1 minus 3. So what can we actually do there? Well, we can actually reduce that a little bit more. Negative 7x, this 1 minus 3 is going to become negative 2. So what we can eventually do, if we wanted to get real fancy, negative 2 times negative 7 is going to give us 14x. Okay, for these ones, factor each polynomial. So really what I want you to do here is just take a look at what's common between everything and just take that out, and then we'll worry about the rest later when we get into a little more in-depth factoring. So for this, factor each polynomial, we're going to take a look. We're going to factor out that 3, and then we're left with x squared minus 4x plus 6. And soon we're going to learn how to factor those. Okay, next we're going to take out, from here, we're going to take out a negative 10 because everything has a 10. So we can either take out a positive 10 or a negative 10. I just always like having this x squared be positive. So I'm going to take out a negative 10, so that x squared. This plus 20x, since I took out a negative 10, we need to reverse the sign. So it's going to be minus 10x. And then we have positive, back it up. That's going to be minus 2x, and this is going to be positive 3. It makes a lot more sense now. Okay, for this, what's common between these things? Well, everything can be divided by 3, so I'm going to take a negative 3 out, and that leaves me with 3x squared plus x and minus 3. Yep, that looks good. And then over here, I'm going to take a 2 out, so that's going to leave me with 2x squared minus 3x plus 4. For this, what can we take out? Well, you're going to notice there's an x in both of these, so we can take that out for sure. So I'm going to take out 6 and an x, and that's going to leave me with x plus 2, right? Make sure you're dividing. This one I'm going to take a 9x out, and that's going to leave me with x plus 2 again. This one I'll take a 4x out, that's going to leave me with x plus 6, and here I'm going to take a 15x out, and that's going to leave me with x plus 2. If you ever want to check your work, and you're like, oh, I don't know if I got this right, let's take a look at C. If we want to check, we can just go in reverse. We'll multiply everything back in together. 4x times x, 4x squared. 4x times 6 plus 24x. Is that what we started with? It definitely is, so we're on the right track. Okay, for 7. 7, a swimming pool has the area that is shown there. So we're going to factor completely the expression representing the area. So we're going to be able to determine the length and the width of the swimming pool. Okay, so here we're going to take a look at our area equals x squared plus 5x. Perfect. So let's factor this out. So what's common between these things? Well, x is common, and we're left with x plus 5. So we can say this factor here could be our length, this could be our width, or vice versa. It doesn't really matter. So find the actual measures of its side if x equals 2 meters. So if we said this is our length, and we know that x equals 2, so if we're looking for our length, we said that in that case, x equals 2. For our width, we have x plus 5, but we're going to substitute 2 in. So we have 2 plus 5, so that is going to equal 7. So now, since we have those things, we can find the perimeter. And remember, perimeter of a rectangle is 2 times L plus 2 times W. So 2 times our length, which was 2, plus 2 times our width, which was 7. It's going to give me 4 plus 14, and I'm going to get a perimeter of 18 centimeters. Perfect. Find the dimensions of each rectangle. Okay, nice and easy. So we have our area equals 21x squared plus 3x. So what's in common there? Well, we can factor out a 3x, and that leaves us with 7x plus 1. So we'll say that is our length. That is our width. The next one, we have area equals 2x squared plus 18x. And what's in common here? Well, there's a 2x that's in common. That's going to leave us with an x when we divide that out, plus 9. So we'll say that is our width, and that is our length. And I have eliminated this from your homework, so that will take us to the end of this lesson.